Morning, ELL fundamental students. I can't believe we are in our last week of second semester, but I wanted to review the major topics that we've gone over. It is very, very important that you are familiar and pretty confident with these skills, as most of you will be moving on to Algebra 1 in the fall and are going to be using all of these skills at a higher level. So feel free to watch this video as many times as you need to. You can take your own notes, whatever you need to do, but I will also have an assignment posted with problems that are similar to these, so you can use the video as a reference. So for number one, evaluate, we are looking at this expression and we are taking this -3 value and we are plugging it in for any x that we see. So I'm going to rewrite it. When we substitute in a value, it's a good idea to put it in parentheses. Now, before I start evaluating there, I want to review the very important order of operations. So remember, that stands for parentheses, exponents, multiplying or dividing, whichever comes first, adding or subtracting, whichever comes first. So for this problem, we do have parentheses, but there's nothing to do with them. So that's already done. Then we look for exponents. We have that here. Don't forget, this is multiplication in between here. So I'm going to keep that like that. -3 squared is -3 times a -3, which is a +9. So exponents are done. So now we will multiply or divide. There's no division, we just have multiplication. So 2 times 9 is 18. 8 times a -3 is a -24. So we've done the multiplication and division. Now this is also the same as this, whether you're adding a negative or subtracting the 24. Either way, we're adding or subtracting. That's going to result, we have more negatives than we do positives here. That's going to result in a -6 final answer. Okay, so that's how we evaluate and follow this order of operations. Now, simplifying means to combine like terms and make it as small as possible. Distributing is referring to that situation where we're going to multiply. So if I rewrite the problem over here, if we follow our order of operations, we should be multiplying before adding. So I'm going to leave these as is. This distributes to be a 3x. 3 times x is 3x. This distributes to be 3 times -4, which is a -12 or a -12. Now, in order to combine like terms, we need to label. Those are like terms. These are like terms. So 4x plus 3x would give me 7x, and +7 minus 12 would be a -5, and there is our final answer. That is now in simplified form. Okay, another key term, solve. So solve, we are trying to find the x value that makes this side equal to that side. We're trying to find the x value that makes this side equal to that side. Two separate problems. So remember, with solving, we're going to do the reverse order of operations typically. So I'm actually going to want to look to add or subtract first. So I'm trying to isolate this x. So I'm trying to get rid of these numbers. Let's get rid of the -3. So we undo adding 3 by subtracting 3. We do that to both sides. So that leaves me with x over 2, that's gone, equals 8. Then this operation right here is division. We will undo division with multiplication. So I will multiply both sides by 2, and I get x is equal to a +16. I can check that answer by plugging it back in. 16 divided by 2 is 8. 8 plus 3 is 11. Check. Now, what's different about this one is that we have variables on both sides. So the key is to get all the variables on one side. I prefer typically to go to the left side. It doesn't matter. So if I want to bring this over, that's a +6x. So I have to subtract 6x from both sides. So this would be gone, and I'm left with a -1. This would give me -2x minus 7. So again, I'm trying to isolate this x, so I want to get rid of the minus 7. So I will add 7 to both sides. And I will get negative 2x equals 6. Negative 1 plus 7 is 6. And then finally, this is multiplication here, and we undo multiplication with division. So I will divide by that same number. Why? Because this is just 1. It's 1x. That's what we want. This is a negative 3. There's my final answer. Now, if I plug that in here, I would get 4 times negative 3, which is negative 12, minus 7. That would be a negative 19. If I plug negative 3 over here, 6 times negative 3 is negative 18 minus 1 is negative 19. That's equal to that. Check. That's a very important topic that you will be applying quite often when you get into Algebra 1. So make sure you remember those undo operations. Okay, a couple new topics that we went over this semester. We're evaluating new symbols that we learned. This was all learned when we did the remote learning. So the square root of 36, remember that is asking what number times itself gives us 36. That would just be 6. Square root of 100 is what number times itself gives us 100. That would be 10. This symbol is the absolute value symbol. And so that is always asking, hey, how far is that number from 0? And since it's a distance, it will always be positive. So absolute value of negative 8 is going to be 8 because it's 8 units from 0. Now here, the absolute value of 13 minus 9, we will first do our operation inside. So 13 minus 9 is 4. So now what's the absolute value of 4? Well, how far is 4 from 0? Well, it's just 4. Okay. And then lastly, this here, remember if there's no operation, that is multiplication. So I write 5 times, but I got to figure out what is the absolute value of negative 3. How far is negative 3 from 0? Well, it's a distance of 3. So 5 times 3 would be a positive 15. And you'll see more with absolute values in Algebra 1 as well. Okay, now this was kind of a first semester topic, but we use it throughout second semester. You're going to see it throughout Algebra 1, and that's making sure we know how to do operations with fractions. So let's look at the part A. Here we are subtracting. Now we have the same denominators, so we actually can subtract these. 4 minus 1 is 3 with that same denominator. 4/5 minus 1/5 is 3/5. Now, if we have different denominators, then we are not able to add or subtract them immediately. So we have to change those denominators. We need to get them the same. Here they were the same. Here they're not. So in order to add these, we need to get these the same. So 3 and 4 both go into 12. So that means I'd have to multiply this by 4 to get 12, and I'd have to multiply this by 3 to get 12. Now, whatever you do to the denominator, as we call it down here, you also have to do to the numerator. So if I multiply this by 4, I have to multiply the top by 4. If I multiply this denominator by 3, I have to multiply the top or the numerator by 3. And so now we have those new fractions. Now these are still equivalent to the original ones, but now the denominators match. And now I can combine these. That stays as 12. 8 plus 9 is 17. Now that's one way to answer it. Or we could say 12 goes into 17 one time. And how much is remaining? Well, there are 5 remaining to go from 12 to 17 over that original 12. And that would be an answer as well. So these are two numbers that look different, but they have the exact same value. This is called an improper fraction. This is called a mixed fraction or mixed number. Okay, now multiplication. Good news with multiplication is you don't need the same denominator. So I could multiply across the top here, and I could get 60 over 15. And then I could try to simplify that from there because I still have big numbers. But in a way to order or avoid the big numbers, we can simplify from the start. So 6 and 3, those can both be divided by 3. So that would become a 2. that would become a 1. Well, 10 and 5 can both be divided by 5, so that would become a 1, that would become a 2. So now when I multiply across the top, I get 4. When I multiply across the bottom, I get 1, and that will simplify to be 4. 60 divided by 15 is also 4, so either way you go, you're going to get a final answer, 4. Now, for division, it's going to be similar to multiplication, but we first have to change it. So I'm going to change division to multiplication, and then we are going to flip this fraction, or find the reciprocal. So the reciprocal of 3/5 is 5/3. So I changed this division symbol to multiplication, and therefore I had to flip this fraction. Now I can multiply. I don't have anything that would cancel with the 2 and the 3 or the 5 and the 7. So I'll multiply across the top and get 10. I'll multiply across the bottom and get 21, and there is my final answer. So that's a quick review of the 4 operations working with fractions. Okay, lastly, this is what we've covered the last week or so. You're going to do a lot of graphing in Algebra 1. So you'll be graphing lines, some parabolas, maybe some other shapes. But I want to make sure you can go into Algebra 1 at least knowing how to plot points. So remember, this is called the x-axis here. This is called the y-axis. This is what we call quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This right here we call the origin. It's the beginning. So if I want to plot the point -4, 2, remember this is my x and this is my y. Just think alphabetically. In the English language, x comes before y. So that means you're going to go horizontally on the x-axis, because this is -5, this is -10 here, this is 5, this is +10. So I want to go to -4, and then I want to go to a +2, so I'm going to go up 2, and there's my point A at -4, 2. For B, this is a +5, so I'm going to go in the positive direction 5 units. Then I'm going to go down 1 in the vertical direction, or the y direction, and that would be my point B. And for C, this again is my x, this is my y, so I don't go anywhere horizontally, but I do go vertically 7. So that would be this point right here, which would be the point C. And lastly, for point D, there's my x, there's my y, so I go in the x direction, -8, and then I don't go up or down, so this right here would be my point D. And that's a quick review on how to plot points on a graph. So again, feel free to watch this video as many times you need to write down notes, but definitely use it as a resource when you're doing your final assignment this week.